Hi, Erica. To start this problem, I'm just going to do part B here. It's asking us to find the volume of the solid generated by revolving the region bounded by the parabola y equals x squared divided by 25 and the line y equals 1 about the line y equals 2. So the very first thing you should do is you should draw the region, the two-dimensional region that's enclosed by those two graphs. So y equals x squared over 25 is a really wide parabola. And if you plug in positive 5 and negative 5 for x, you'll get 1 for y. And it also goes through 0, 0. You could get these points and what this graph looks like just by using your graphing calculator. So it's a really wide parabola. And then we also want the line y equals 1, which is just a horizontal line that goes through these points, goes through y equals 1. So this is the region that we're talking about here. That is the region that's enclosed by y equals x squared over 25 and y equals 1. And then we're asked to revolve this around y equals 2, which is right here. So when we take this region and revolve it, for the graph, the first thing we have to do is reflect it. And then because it's a revolution, it'll have these circular cross sections. So it looks kind of like a bead or something like that. So there's two things going on here that make this problem a little bit tricky. First of all, it's hollow. Everything in there is hollowness, which means we're going to have to do the washer method. Also, we're revolving around a line other than the x-axis. We're revolving around y equals 2, which means everything in this graph needs to be shifted down 2 units. And the way we do that is we just subtract 2 from our functions. Also, when you're deciding in the washer method the inner function and the outer function, you always draw an arrow through your region pointing at the axis of revolution. The first graph that it crosses is your outer radius, and then the second graph that it crosses is your inner radius. So there's a couple things we need to do here. We need to shift our graphs down 2 units so that our axis of revolution lines up with the x-axis. So we're going to take our parabola, and to shift it down 2 units, you just subtract 2. And there's nothing we can do there to simplify that. And then we take our horizontal line y equals 1. If we shift that down 2 units, it simplifies to y equals negative 1. So this is our outer, and this is our inner. And when we do washer method, those radii get squared separately. So the volume is pi times the integral of your outer radius squared minus your inner radius squared. And then for the bounds, we want to know where those 2 graphs meet horizontally. Because all of our functions are written in terms of x and we're integrating with respect to x, these bounds should be x values. And these 2 graphs intersect at negative 5 and positive 5. So ultimately, the integral that we're trying to calculate is pi, integral from negative 5 to positive 5, of x squared divided by 25 minus 2 squared minus negative 1 squared with respect to x. If those intersection points, the positive and -5, you can get by just graphing these two functions and see where they intersect. You could also get them algebraically. Two graphs intersect when they are equal to each other. So you also could say, well, where does x squared over 25 equal 1? You multiply the 25 over, and you get x squared equals 25. And then you square root both sides, and you get x equals plus and minus 5. So you could do it graphically. You can graph those functions on your calculator and see where they intersect. You also can work this algebraically and get positive and -5 that way as well. So to finish this off, we're going to have to FOIL this piece. So we get pi -5 to 5. FOILing that, 25 squares is a really big number. Give me just a second. Not one I know off the top of my head. So we get x to the 4th over 625 minus 4x squared over 25 plus 4. And then -1 squared is +1, and we're subtracting that. And once that's expanded, you can now combine those two and then just use your power rule. So that's really +3. And then the power rule just says add 1 to your power and then divide by the new power. So that's going to be x to the 5th over 5. So we multiply the 625 by 5. And we get x to the 5th over 3125 minus, and that's going to go up to x cubed over 3 will be 4x cubed over 75 plus 3x. And this needs to be evaluated at +5 and -5. So if we start with our +5, we need to do 5 to the 5th which is 3125 minus 5 cubed, which is 125 times 4 plus 15. And then we subtract what we get when we plug in -5, which is going to be the exact same numbers but opposite signs. So -3125 over 3125 plus 500 over 75 minus 15. Now, they don't cancel because they're opposites, because technically we need to distribute this minus sign to all of them. So this is 1 minus 6 2/3 plus 15, and that's plus 1 minus 6 2/3 plus 15. So for my whole numbers, I've got 32. And if I put those fractions together, we get 12, 13 1/3. So for an exact answer, you're not going to want to use decimals. You want to be able to combine these. So if you want, you can put everything in terms of thirds. This is 96 thirds minus 40 thirds, which is 56 pi over 3. So just to recap really quickly, the very first thing you should do, no matter where they say you're revolving around, is always draw the two-dimensional region that they give you from the functions. And then I also drew my axis of revolution. The bounds, which was your specific question, are the points where our two functions intersect. So I hope that helps. If it does not, just email me back and let me know how else I can help you with this.